lecture 28. In this lecture, we will be showing you the experiment with speaker. Okay. So, we will be interfacing a speaker with STM board, and we will generate 4 different kind of tones. So, firstly we will look into that how the connection diagram will be. PWM port we have already discussed in detail in week 3. So, I will be using some of the functions that have been already discussed, which I will be using along with the speaker, and then I will be showing you how we can make different kinds of signals, different kinds of sound through a speaker using changing the codes. Okay. So, let us move on. So, firstly how speaker is interfaced, we will show the circuit, and then we will look into the various experiments with speaker, and finally I will demonstrate. So, how does a speaker work? It has been already discussed in previous week. So, I will very briefly say regarding this. The speakers work by converting electric energy to mechanical energy. Okay. The mechanical energy, it compresses the air and converts the motion into sound energy or sound pressure level. Okay. So, inside it there is a permanent magnet, some voltages are applied, and then there is a coil through which it generates some kind of sound here. Now, how do we interface it? How do we interface a speaker? If you think of any waveform in an audio frequency range from an output port can drive basically the speaker. But sometime we see that we may require an amplifier circuit to generate the adequate power for the electromagnet, that is required. Okay, amplifier is required. So, this is a typical circuit diagram. Okay, so this is one end of the speaker which is going to V out, and another end through this transistor is connected, one through this resistance and another through ground. This is a typical a simple transistor based amplifier circuit. Although in our case we have not used any kind of circuit, but it might be required to use such kind of circuit when you interface a speaker. Okay, let us move on. We have interfaced a small speaker. So, in that case we have directly connected to the port lines. So, it can also be driven directly from the port lines of the microcontroller, but we have to connect to a PWM port line. So, this is the digital port. These are the two ends of the speaker. One is connected to ground, one will be connected to PwmOut pin. Okay. This we must remember. Of course, we will not be able to generate a very high end sound, but a reasonable amount of sound which you can hear, you can generate through this PWM port if you directly connect it. As I told you, we will be doing couple of experiments. So, the first experiment that we will be doing is, we will be generating a fixed tone on the speaker by generating a sound wave of a particular frequency, which we will use it to drive the speaker. Okay. A fixed tone we will be generating. We all know that the audible sound, that the frequency range for an audible sound is 20 Hz to 20 kilohertz. In this experiment, we generate a frequency of 250 Hz, which will be audible to us. We can use the pulse width modulated port to generate the speaker control signal, by specifying the following. What we need to specify? We need to specify the time period of the generated waveform, which is nothing but 1 by frequency, and the duty cycle of the generated waveform, that is time period which is on divided by the entire time period, that is on plus off. These are the few things we need to remember. Now, these functions we have already discussed in previous weeks. PwmOut, what it does? It creates a PwmOut connected to the specified pin. So, whichever PWM pin we will be connecting it to. So, once we use PwmOut with that pin name, we can create this PwmOut signal to it. Void write some float value. What it will do? It will set the output duty cycle specified as a percentage. Okay. The percentage time it is on. Okay. So, that can be written using this function void write. Similarly, void period. We can also set the PWM period in seconds by specifying, by using this particular function void period and specifying in this parameter the seconds. Okay. So, these are the few functions that I have discussed. There are many more functions which has been discussed earlier in detail. So, as I will be using this in this particular lecture, so I have just told you about this once again. Now, this is the circuit diagram. Circuit diagram is fairly straightforward. You will see that when I demonstrate, I will simply connect one end of the speaker to ground and another end of the speaker with PWM port, that is the D3 port of this STM, okay, which is a PWM port. There are some fixed PWM ports. You can use any one of those PWM port for this purpose. Okay. Now, I will be showing you a series of programs. The first program, this will actually generate a fixed tone. Okay. The fixed tone which is of frequency 250 hertz. Okay. Let us see how. Digital out speaker which is connected to D3, int main, and we are outputting speaker with 0 with a weight of 0.002 second, which is 2 millisecond, and speaker equals to 1 with weight of 0.002 millisecond, which is 2 millisecond. Okay. So, we are generating a fixed tone where we are sending a 0 once and a 1 once, and this is the period, that is 2 millisecond and 2 millisecond. So, 2 millisecond it will be on, 2 millisecond it will be off. Okay. So, this program does not use PWM. As you can see, we have just done digital out and not PWM out. Okay. Because we want a fixed tone and we do not want it to change. Okay. It is a fixed tone that it will be generating, and it simply outputs either 0 or 1 alternatively with a time period of 4 millisecond. As I said, 2 millisecond on, 2 millisecond off. So, total period is 4 millisecond, and which is equivalent to 250 hertz. Okay. So, we will demonstrate this particular at the end of this lecture. Experiment 2. In this experiment, what we will be doing, we will generate two frequency tone of the speaker alternatively between 333 hertz and 455 hertz. How do I do it? Playing each frequency tone for 0.5 second. So, both will be played for 0.5 second. So, the first tone will be of 333 hertz, the next will be 455 hertz. Okay. If it is 333 hertz, the time period will be 1 divided by 333, 1 divided by 333, which comes down to 3 millisecond basically, and it is 455 hertz. So, 1 divided by 455, which will come down to 2.2. Okay. That is the time period that we have specified, and we repeat this process. Okay. So, we have to first generate a tone of 333 hertz, then 455 hertz, and I will repeat this again. Let us see the code, how it goes. This is the Mbed code for it. In this particular code, you see that first of all this is PwmOut, which is D3, which is PwmOut, and we are using two functions, period underscore microsecond and pulse width underscore microsecond. This is specified in terms of this microsecond. Okay. So, what we are doing my PWM period in microsecond 3000 and my PWM pulse width underscore US, that is microsecond, is 1550. We are specifying these two parameters here. These two parameters are used for the purpose of generating this tone. Then what we are doing? Then we are doing my PWM dot period in microsecond, this one, my PWM pulse width of this one, then we wait for 5 millisecond, because I said that it will play for the first tone for how much period? For a period of 0.5 second, and again it will play a tone which is of this period for another 0.5 second. So, that is what we are doing it here. So, we are specifying these two things here, we wait for 0.5 second, again we specify these here and we wait for 0.5 second, and this repeats. So, we will see that this will generate a siren like sound. So, it will be T, 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 T like that. Okay? So, we will look into that when we show the demonstration. Okay. The next experiment that we will be showing is to generate 12 musical notes of an octave on the speaker. Basically, it is sa, re, ga, ma, pa, dha, ni, sa. Okay. So, we start with the base frequency, let us say 300 hertz, and then what we do, the frequency of the next tone is generated by multiplying it with 12th root of 2, which is 1.0595. So, first I will start with 300 hertz. The next tone will get generated by multiplying it with this particular value, and then the whole things repeat for 12 tones, and again it goes back to the first one. Okay. So, for this the code goes like this. So, this is the code. Again we use this PwmOut for the speaker, which is connected to D3, and here we set a duty cycle which is 0.5, speaker dot write 0.5, we are specifying the duty cycle, and then frequency is 3000. Then how do we calculate the period? Period will be 1 divided by frequency, because for each one now we have to calculate, depending the next note will be calculated by multiplying certain value to this frequency. Okay. So, that is why period we are calculating, which is 1 divided by frequency. Then we are setting the speaker period as this period. Okay. Please see, the period we are calculating here, and then we are setting the speaker period as this period. We wait for 0.5 second, then the next frequency that is getting generated is again generated by multiplying the frequency, which is 300 here multiplied by this, that will become the new frequency, and again that is divided by 1 divided by that particular frequency, and that will get output, and this will happen for 12 notes, and again it will repeat forever. So, this is what is done to generate a tone for sa, re, ga, ma, pa, dha, ni, sa. The next successive note here in this experiment, we will be actually playing some successive note of a musical piece is played, and which will sound very similar to like happy birthday to you. Okay. So, we have selected few notes, few frequencies that we have played for certain period to generate that particular tone. Let us see the code directly. So, this is the code. Here you can see that what we are doing. We are actually taking the first frequency, that is 262, we are outputting it speaker dot period. Then we wait for 0.5 second. Then it is frequency is again 262, okay, and again we calculate the period which is displayed. Next frequency becomes 294, okay, and then it is displayed, okay. Then again it is 262 and then again it is displayed, then it is 349, 330 and so on. So, this whole thing, if you see, if you run this particular code where we are doing nothing but we are specifying certain frequency and we are generating that time period and we are writing it to the speaker and it is generating certain sound. So, it sounds like to some extent happy birthday to you. We will be looking into all the four codes that I have just now discussed. After this, I will demonstrate each one of these codes using the speaker connection. So, this is basically all about that I have to tell you regarding speaker, and then I will move on and I will show you how do I interface this, how do I interface this particular all the four codes using a speaker and a microcontroller board. So, now I will be showing you the four codes on speaker that I have discussed just now. Okay. So, those four codes, what they were doing? They were essentially doing like the first code will just make some sound, make some random beep sound for a longer period. What the next code was doing? It was doing a sound like siren. Okay. It will be something we all have heard of, siren like sound. So, it will be making some sound like a siren. Then the next code, basically there are 12 octaves that we have for that sa re ga ma pa dha ni sa. So, here I will be just playing the first 8 one, that is sa re ga ma pa dha ni sa, and again it will repeat like sa re ga ma pa dha ni sa. So, this with a wait period it will go on repeating. This is the third code, and the fourth code that I have shown you, that is like a code where this tone of this happy birthday to you will be played. Okay. So, what I will be essentially doing now is that those four codes which I have discussed, I will show you first that how you will be connecting the speaker using STM board, and then how you will be dumping the code one by one. I will be dumping each one of this code and we will see that whether the sound is coming from the speaker or not. Okay. So, let us look into the circuit. Okay. So, this is a speaker, right. So, this is a speaker that we discussed. So, inside this, the mechanism of the speaker I have already discussed, what it is actually doing. The mechanical coil is a magnet and how it is repelling and going away. So, that mechanism is performed in this speaker. What I will do, you can connect any of these end. One end I will put it into the ground, and the other end I will be putting it into the PWM port. In this board there are many PWM ports which are there present here, out of which I will be using the D3 port. So, I will be connecting one end to this D3 port, which is output port as well as PWM, and another one I will be connecting it to ground. This is the connection that I will make, and then I will be dumping 4 code, as I said. Okay, I have already discussed about the various functions using the PWM port. Okay, so there are many functions that we can use. Some of the functions we have used in this particular code for the speaker. So let me connect it. So I will be connecting one end to the ground. And another end I will be connecting to D0, D1, D2 and D3, which is PWM. It is written. If you are already working with these boards, you can see it is written PWM/D3. Okay, so this is all you have to make. And now I will be putting up the codes one by one. So the first code will be a constant sound that it will generate. You can hear this sound that is coming, which is a constant sound that with a single frequency sound it is just playing. Okay, so now we'll go to the next sound. Okay, so I'll just take this out. So now I will be dumping the next code. So basically this is the code of a siren. So you must have heard of the sound when some ambulance come. So it blows a sound like some kind of siren sound. So let us see how we can generate that. Okay, so well, just a second. It is glowing the old sound. Yes, now it is glowing the siren sound. So this is a kind of sound using the code which I already discussed. It is playing. Okay. Okay, now we'll move on with the next one, which is basically sa re ga ma. Okay, so next I will dump the code that I have discussed with you using this sa re ga ma node. Instead of 12 octave, I am just playing the first 8 one. You can hear the sound. So sa re ga ma pa dha ni sa. So what is happening here? It is playing sa re ga ma pa dha ni sa, and then again there is some small delay, and then again it is playing sa re ga ma pa dha ni sa. Okay, so the code which I have discussed, it is doing the same thing here. Next I will just play the happy birthday tone. This is also some kind of tone that we can play. So let us see with the code that I discussed. Just a second. So it may not be the exact sound, but it is pretty similar sound. Okay. Okay. So the experiment using speaker was very straightforward. There was nothing much that we have to connect. one port, one point of the speaker I connected with T3, another point I connected with ground, and I have dumped the 4 codes that I already discussed with you, and one by one you can see that this is how a speaker works. But where you can use this, you think of a scenario where you will be doing some kind of experiment where you want that if something happens, then you make the sound of a siren. Okay, so this is quite a small sound. You can even have a sound which is much more louder. Okay, that also you can make. So you can have something like this, that for security purpose you have a lock. Okay, let's say you are not in your house during a summer vacation, you went for a vacation, and then what you can do is that you can put some kind of sensor that if somebody touches your lock, a particular part, because if somebody has to open the lock, they definitely will have to touch some part of the lock. Okay, so you can put the touch sensor there, and if somebody touches, then a sound like siren will come in. Okay, and if you are staying in a place where there are many other houses, so they can really make out that okay, something is happening which should not happen. So some kind of, I'm just giving you an example here. It could be any application where you can use this speaker. Okay, thank you.